So yeah, hi again. My name is Nastya Zlenko. I'm a software engineer at the Grammarly business team at Grammarly. Our team, like my team, Grammarly Business, is focused on creating product offering that helps improve writing at an organizational level. For instance, we're allowed to create custom Grammarly checks and create a library of snippets, snippets of text that are used frequently. I'm a front-end engineer on the team, and I help building all of these cool features in our products. I'm pleased to moderate today's meetup featuring two of my colleagues, Denis and Levzhynskyi. For those who haven't attended our previous events this week, Grammarly Tech Week is an event series hosted by the Grammarly Ukraine team. Over 5 days, our team members have been holding 5 online meetups, sharing insights from our work. Tomorrow, we will have our last meetup this week, where Denis, product manager for the Grammarly editor and product consistency teams, will tell us about the hidden complexity of NLP/ML products from a product manager perspective. I highly recommend attending this meetup as well. Grammarly events have always been free to attend, and we keep this tradition. This time, though, in the light of Russia's aggression against Ukraine, we invite meetup participants to make a voluntary donation to trusted organizations supporting the people of Ukraine. You can find a list of suggested organizations via the QR code on the slide, or select any fund of your choice. Any amount matters. There are no small donations. Every contribution will be valuable. Needless to say, Grammarly continues to stand with Ukraine, and we immensely appreciate your support. And a couple of words how our today's event will go in. So today we will have a networking session. Our events are intended as an opportunity for you to connect with new, interesting people. So after the talk, Q&A session, we will invite you to join a Zoom call for a more informal group conversation. There you will have a chance to chat with our speakers, Denis and Levzhynskyi, and others from the Grammarly team. You can find the link for that call in your registration confirmation, and we will post it in the Zoom chat here at the end of the presentation. So you are very welcomed and encouraged to come and talk with us and with each other. A little information about the Q&A session. During the presentation, please submit your questions to the Q&A tool, and our speakers will address those after their talks. And rest assured, there is an opportunity to ask Levzhynskyi and Denis about things you're interested in our networking session. And with these logistical matters behind us, let's now get to the main part of the meetup. Levzhynskyi and Denis will talk today about how we test at Grammarly. And I'm thrilled to welcome Levzhynskyi, tech lead, who will tell about general process of testing the front-end apps.
Thank you so much, Nastya. Hello, everyone. My name is Levzhynskyi. I'm technical lead of browser extension. Basically, it's browser extension. We are building extension for multiple topmost browsers. And also, I used to work in online editor, by the way, together with Denis Kashkovskyi. At Grammarly, as you may know, we have a lot of clients for different platforms. First of all, I already mentioned that we have browser extensions. Also, we have desktop applications for macOS and Windows. Also, there is a keyboards for Android and iOS. Also, we have a web editor, and recently, not so recently, probably a year ago, we released an SDK, so any developer could inject, attach the Grammarly SDK to your own site and get the whole power of Grammarly suggestions. Today we're going to talk, me and Denis, we're going to talk on example of online editor application. It's online editor is basically a place where users could store and edit long and huge documents and get everything everything what Grammarly suggests. My first part would be more about quality at Grammarly and how we think about it. When the Denis part would be more practical, he will talk about how to basically test and write code for tests to test reactive code. Okay, we at Grammarly believe that quality is the primary responsibility of software engineer. It's kind of engineers has a few primary goals, but yeah, one of them is quality. At current setup, we don't have QA engineers or developers. Engineers are fully busy with testing and thinking about quality. This for sure, this may be changed somewhere in the future, but right now we are okay with this approach, and it works well for us. Okay, then how do we ensure the quality of our features? How does it work? So basically here I would like to talk about the whole flow of development of some typical feature, and basically I would like to show that we are thinking about the quality basically on every step. It's so the quality is not about testing. And testing is not about basically writing tests, but it should be placed on all stages. So what goes first? Me at Grammarly, as many other companies, having some goals, having some high levels areas that we would like to improve. Basically, it could be. For example, it could be some improving on some suggestions for some particular group of users, whether it could be students, it could be some professionals or whatever, or we could let's say there's some high level goal. It could be let's say we would like to improve integration between our clients, so the transition between them would be much smoother, or the goal could be performance improvements or whatever. And the product, each team basically, or each group of project has dedicated product manager, and this product manager, according to these goals, according to discussion with the team, gathering some ideas and picks features that it wants to develop basically to achieve these goals. Then product manager together with designer makes some high-level specification. It's bullet points of what we would like to achieve. It could be some high-level mocks of how this feature could work. And when this initial draft is ready, product manager asks some engineer or group of engineers that potentially could work on this feature, or who has a kind of context and understanding on how this could be implemented. So basically, product manager asks these engineers to review this specification, and it's really important because at this point, engineers already understands why we're actually doing this feature. What's the reason of behind this feature, and basically engineers could see the bigger picture from the start. So basically, what other similar probably feature we may make in the future, and at this point it's very important to get a feedback from this engineer. So basically, you may think of it like engineer could provide some estimation and suggest how to narrow the scope if feature is too complex. For some primitive naive example could be like designer draw some fancy button with, let's say, pretty cool animations, but engineer could in this case provide some feedback like, okay, this button is cool, but to implement this button, we need to, let's say, gather 3 teams, have a 1 month collaboration, and finally it will be ready. But you know what? If you will, let's say, move it by 10 pixels, then it would be only work for 1 team and for 1 week. So yeah, it's definitely a naive example, but it's really important on this stage. When the specification is ready and we are ready to develop it, we know that, let's say, next month, in next quarter, we would like to release it. Then we move to the planning phase. At planning phase, engineers are working on kind of breaking, they are breaking down, doing breakdown for this feature, defining together with product managers. They defining the milestones, they defining the release plan, defining whether we need to do a A/B test and actually start thinking about the architecture of this feature. When the planning is ready, we are moving to the coding phase. Basically, it's obvious. However, in the middle, somewhere in the it could happen during the planning phase. It could happen right after the planning. We are usually doing the architecture review. What is architecture review? Basically, architecture review is another layer where we could think about the quality and before that to kind of find the possible issues and bugs in production. When we use it, architecture review, it could be a formal meeting, it could be a few meetings, or it could be just a formal discussion, few minutes discussion. It really depends on the size of the feature. If the feature requires, let's say, the change of client-server communication, or if feature requires change of the architecture of how few models, let's say, connects one to each other, then it worth to create some document. We are usually using some sort of drawing, whiteboarding, drawing with a whiteboard. We could create some diagram of or create some interfaces, and then the engineers that are working on this feature ask the team to provide some feedback. We are using an approach called RFC or ADR. It's kind of similar. Basically, they have different format and probably this approach is on different stages, but the goal is kind of similar. It have document that could be commented to gather some feedback for upcoming architecture changes. This phrase basically helps us to narrow the scope of coding and figure out how it could be implemented in the best possible way. After that, after we know the milestones, we know the architecture, what we should change and what we should basically do, engineers move into the coding phase. It was to mention that we are using the framework called DRI, directly responsible individual. So basically, for each particular feature, we have some dedicated engineers. It could be basically few engineers, but usually the one who is kind of working on facilitating all planning and architecture review. This is the one who has the full context of this feature and basically knows the state of this feature. Where are we now? Where are we heading? How many time do we need to spend on one or another phase? Okay, moving on. Basically, coding is impossible without writing tests. We are not usually using the TDD, but rather we are writing codes and then covering it with units. But anyway, we believe that the code quality and that the good code is always comes with testing. So that's why when we are thinking about estimates for some task, we usually including time that needs to write units. And when we are thinking about the features as a whole, we also dedicate some time for end-to-end testing or some specific testing that could be needed. For sure, end-to-end tests Usually it's kind of a separate task, but anyway, after when some feature is kind of done, we are working on end-to-end tests. Also, there are a lot of different tests. Kind of we are doing integration tests. It's more like integration between models or integration with backends. Also, we are always thinking. So the quality is not only that feature works, but also it is that features kind of works for wide range of our users. So we are basically thinking of the delightfulness of the UI, and we are thinking about the accessibility of our features. Okay, and the sort of final, not the final, but almost final level before the release, final layer, sorry. When we are once again validating the quality, verifying the quality of our code and of our product is code review. Code review is a good place where someone could spot some issues. Basically, we are trying to think of code reviews that it's not about, just spotting that there is not some strange code style. You missed a semicolon, or you missed you selected some wrong name for variable. But it's rather to kind of try to spot the logical issues. And yeah, it's hard. So basically, code reviewers should also have a context of why and what's going on. And also we practicing during the code review, we are practicing exploratory testing. So reviewers could open the site, open the branch, and or open the applications that corresponds to this merge request or pull request, and do exploratory testing. So basically verify that it works as expected and try to break it a bit. When the pipeline is green and everything is ready to release, we have two ways. There are two ways. The first one is simple one, just release to all users, and another one is A/B test. We are heavily relying on A/B testing. Basically, we are releasing some new feature and under the experiment, and comparing it with, let's say, not a legacy but existing feature, current feature. And we are actually looking on the engagement whether this feature is understandable for the user. For example, let's imagine we improved some check for passive voice. Okay, it's much our suggestions provide much more information about whether it's really what the user needs. And the A/B test is a good way to validate that our UI is understandable, our UI is work as expected, it's the behavior is really delightful for the user. I mean, the animations is good, everything is work the best. For sure, if A/B test is successful, then we just do a regular release. Otherwise, we could return back to any previous phase. We even return to the specification, or for some features, we could decide to get rid of it and remove it completely. And the final phase and the final layer that validates that everything works as expected is monitoring of production code, of application in production. So what does it mean? We are gathering some metric, developers metric, business metrics, how user engaging with our application, whether it's still the level of errors or error of interaction is still kind of within the threshold. And this allows us to kind of react as quickly as possible. Everyone knows that it's really impossible to avoid bugs, but it's possible to kind of know when something is wrong before actually every user will leave your application or remove it or install. So we have an alerts that monitor, check these metrics, and if something goes wrong, engineering team gets these alerts and reacts immediately. Okay, sounds good, but are there any challenges? For sure. We believe that continuous delivery is a great way of releasing our code. So it provides a pretty fast release cycle. But continuous delivery is super works the best when the kind of verifying phase it's really fast. So basically, you don't need to spend days on verifying what's going on verifying your latest release. And for sure, if there is a manual regression, it could be for many reasons. It's some specific platform hard to automate or whatever. Then definitely this becoming a challenge. Yeah, in Grammarly, it really depends on the application, but basically for when we are talking about the website, it's pretty easy. It's kind of easy to automate everything, but it's much harder for, let's say, native apps. So still, we believe that automation could help us, and it actually helps. Yeah, sorry, and it actually helps. So as I mentioned, there are a lot of tools, a lot of well-written tools to test the sites in browser. However, there are kind of it's much harder to use these tools, let's say, for extension in browser, because you need to write some abstraction over these tools, because you need to install extension. Different browsers works the best with some particular tools, so you usually need to have some additional layer of abstraction, your own testing framework. So under the hood, there would be some, let's say, Playwright, Selenium, and whatever. And still, it really also the automation. We believe that it's possible to automate almost everything. The only one note that it matters of how many resources do you have and how much time do you have. And yeah, you need to think twice whether it worth to kind of spend 3 months to automate something. Yeah, but basically, all our web applications we are heading to full automation. So it works, let's say, for web editor. It's also we are working to automate everything, let's say, for extension. And back to this diagram, as you may note, that all throughout this flow on all phases, almost on all phases, the primary responsible person is software engineer. So software engineer has the full context and actually on all stages thinks about the quality of the product. And actually internally, we are not kind of deadline driven company. We are more like quality-driven company. So there are some cases when, let's say, our A/B test showed us that the new feature works not as we expected, and we are okay to kind of move our deadlines and back to specification, rethink everything, and let's say spend 1 more month to implement the best possible UI. And what we get, we actually, first of all, engineer has the full context to assess the feature. So engineer from the first stage of specification could select the most suitable the architecture, most suitable solution. He knows of what come next. He may think about the future features and kind of adapt, or at least and build the architectures that will allow to easily plug in the new feature rather than redo everything, let's say, in 1 month. For verification, there are a bunch of stages, like bunch of review stages. So basically, it's design review. I didn't talk about it, but it's architecture review, code review. So there are many eyes that verifies the code and trying to spot the logical issues and trying to spot some bugs and so on. Also, this continuous delivery and this approach, when the engineers kind of has a full context, allows us to kind of build a fast release cycle. So basically, there is no ping pong, no gaps in responsibility. There is some particular group of engineers or engineers that are fully responsible for some particular feature. And what we get, engineers owns product's quality, and more to say, engineers own the product. We believe at Grammarly that engineers, it's not just to write code and kind of solve, or it's to kind of solve the tasks, but engineers more like to provide the solutions, and they have the full context to select and provide most suitable solution for some particular case. And as example of this approach, yeah, as I mentioned, engineer has the whole context about the feature, about the, let's say, product. So basically, they also are free to select the most suitable tool to test it. And as example, it's a story, is the next story from Denis Kashkovskyi. At some point, Denis decided, well, so basically, we have a lot of reactive code. So why don't we using marble testing? So let's try to use it. And you know what? Yeah, we are using it in production. There are a lot of marble tests, and I'm passing over to Denis. Thank you, everyone. Denis, it's your turn. Thank you.
Thank you, Alyosha. 1 second, I'll reshare my screen. Yeah. So I'm Denis Kashkovskyi. I'm a software engineer working at Grammarly for a couple of years in a team that develops a web editor. And yeah, as Alyosha mentioned, we use RxJS very actively in the editor to describe some complex UI logic. In a nutshell about Rex, this tool allows us to express events as streams and work with such streams declaratively. Compose them, take a precise control over time as a variable, and what's an event? It could be everything: WebSocket messages, user inputs, audio streams, etc. Basically, any data that is emitted in time. We also use Focal. It's our small and concise state management library that allows us to seamlessly embed observables into React components layout. So in my part of this report, I'll discuss how we test reactive code. But first, let's imagine an application that we are going to test later. Our application is a very simplified imitation of Grammarly editor. It contains a text field in which user enters their text. Then the text is sent to the server. Server sends suggestions to the received text, and UI then renders these suggestions as cards that the user can apply later. And what's important to our app, the UI should show only relevant suggestions. It takes some time for the server to process the text, and the moment we get this data on the UI, the user's text might have changed, and these suggestions are no longer valid. So let's see how we could express the state of our application using RxJS. We can represent user actions as one stream of events, and messages from the server with suggestions as a second one. The application's business logic should simultaneously listen to these streams and return the application state stream that contains current text and the data for cards. Let's describe the function that creates the state. It accepts the client that exposes a post messages function to send data to the server and the stream of server messages with some card data. The second parameter is a stream of user events, which is a discriminated union of type event, like user enters some text in a text field, and apply event, which is emitted when the user applies the card. And our function returns a stream of application state, which basically represents the current text and an array of card data. So as I mentioned earlier, it's essential for us not to show suggestions to already outdated text. To avoid the situation, we usually introduce the concept of revisions. The revision is a just a simple integer value incremented with each change from the user. And the server sends us suggestions for specific revision. If the revision has already changed on the client, we must ignore these suggestions. So here we listen to user events, create a revision text from them, send these updates to our server, and returning a composed stream of our state from the user text and server messages. Nothing fancy here. It's kind of simplified version, oversimplified version of our editor. What do we want to test in this code? We want to assert that the UI shows relevant suggestions only and ignores ones received for outdated text. But what challenges do we face when testing asynchronous code? First of all, it's logical to assume that asynchronous code requires asynchronous tests. On the other hand, asynchronous tests require additional effort to make them provide quality feedback to the developer. Let's imagine the following scenario. Just we wait in our test, we wait for resolution, let's say, of 5 promises, but the test fails due to a timeout. We just do not know which promise hung up. Okay, and obviously such a test will take a long time to execute, which is not an optimal situation for unit or integration testing. In addition, we may encounter some false positive or false negative results. As the usual example, the test asserts just before the promise result. Also, in such tests, we cannot reliably validate the exact time of an event and synchronism of several events in time, how they behave against each other, the absence of event at all. And what's often helpful in working with observables is the correctness of subscriptions or unsubscriptions. Next, we'll talk about how to avoid asynchrony in our tests. So, marbles. What are marbles? Marbles is a visual metaphor for a children's game of marbles. It's very simple domain-specific language that allows us to graphically describe an observable behavior over time. A marble diagram can contain the values an observable produces, its completion, and possible errors. The documentation for XJS gives us marble diagrams to describe the behavior of each operator. So let's analyze such a diagram for a simple map operator. Map operator, if you are not quite familiar with RxJS, is just the same stuff that we do when we map over arrays, but for streams. At the top, we see the input stream of values. It's represented by a horizontal line that symbolizes the passage of time. On this line, the values produced by the observable are strong. That is, we can say that the diagram expresses the dependence of values on time, where time is a controlled variable. On this straight line, the values produced by the observable are strong, and so intuitively we can assume that by definition, the length of this line will be proportional to the observed period of time. Next, we see that the operator is applied to the incoming stream, multiplying all the values by 10. And at the bottom is the resulting stream, which synchronously emits all the values multiplied by 10. So how can we describe such a picture in our code? To do this, we use ordinary ASCII characters, where the hyphen is the unit of time. It's 1 millisecond by default. And the letter or number represents the fact that the observable value was emitted. And the vertical line at the end is a completion of our observable. This syntax contains also some other symbols, but we won't require them. You can refer to the official Rex documentation to get the full picture. Okay, so we know how to draw marbles in our code, but how does this help us to write a synchronous test, considering that the tested code remains asynchronous? RxJS observables produce values over time, we know that. And the moment at which the value is emitted is controlled by a particular entity, a scheduler. Rex provides us with a special type of test scheduler, which implements a time virtualization mechanism. Simply put, it creates a scope where the time will be marked as described by the marble diagram. It allows us to test our asynchronous code synchronously and deterministically. So let's try to write such a test for the map operator. To develop the intuition, we can treat the diagram as a AAA pattern, where arrange is the incoming stream, act is the operator application, and the third is the equality check of the actual stream and the expected one. We can create a scope of virtualized time with test scheduler's run helper function. Its callback accepts a set of functions such as hot, cold, which creates hot and cold observables respectively, expect observable for stream assertion, and a couple of others. You can read more about them in the Rex documentation later. So here's basically our test. We declare an incoming stream, we declare a diagram of the expected one, we apply our multiply by 10 operator to the incoming stream and compare the results for equality. So let's go back to our application and draw a marble diagram that describes its logic. We have one incoming stream of user events, the second incoming stream of server events, then we apply the already written create state function to these two streams, which returns the resulting application state stream for us. So here, user starts typing. We get an event. We set our text revision to 1 and update our state. User continues typing. We bump revision to 2 and update our state again. Then, what happens next? Server sends us some suggestions for the first revision, but we already know that this revision is outdated, so we ignore them. The user continues typing, we update our state again. Then the server again sends us some suggestions for the second revision, we also ignore them. And finally, eventually at some point, user stops typing, the server sends us some suggestions for the third revision, for the latest one on the client side. And finally, we update our state with these suggestions and the latest text. Let's try to write a test. So again, we create a virtualized scope of time, virtualized time, sorry, using the run function of the test scheduler. We create, before this, we create the test scheduler itself. It's pretty easy to do. You call a constructor of test scheduler and pass the expect function from the testing framework of choice. Then we create a stream of user events, passing the event data, which is basically a record of the letters used in our diagram and the values for the messages themselves. We create a stream of server events in the similar way, where we're passing a server data as a record of the letters from the marble diagram and some array of card data from the server. We draw a diagram of the stream that we expect to receive, create a server, apply our create state function to these two streams, and assert the actual stream to the expected one. So our test is ready. It's concise and easy to read, and such a test can be considered as a documentation for the tested code, as it allows us to understand complex interactions of streams at a glance. We can just look at this rectangle and get a quick intuition on how things work actually. What limitations can we face when working with marble tests? First of all, if you have some RxJS code that uses asynchronous scheduling like promises, you cannot reliably use marble diagrams for that particular code. This is because those other scheduling methods won't be virtualized or known to test scheduler. The solution is to test that code in isolation with a traditional asynchronous test methods of your testing framework. So here we have the example using Jest. where you basically create a generic asynchronous test with done callback and subscribe to promise and call done callback when it emits something. The same goes for delays of 0, because it basically schedules a new macro tasks, so it's asynchronous, but without an explicit passage of time. And the last suggestion relates to the tested code itself. We should avoid uncontrolled subscriptions. So let's check the following example. Here we have the application class that has its state held by a subject. In its constructor, it subscribes to an observable that emits each millisecond, buffers the values each 100 milliseconds, and updates the state with these values. And later, we want to write a test that subscribes to the state for 100 milliseconds and expects that it emits some value. But we end up with JavaScript keep out of memory exception. Why? Because we cannot control the subscription that is made inside of constructor. We cannot unsubscribe from this subscription, and basically this code runs forever, even when our test completes. So let's summarize what are the benefits of such approach. Obviously, we are able to write synchronous tests for asynchronous code. Marble testing works well for unit and integration tests, both of them. The tests are easy to read. They require 0 test code overhead. They allow us to make precise time-wise assertions. And what's important, we actually do not need any third-party library to write these tests, since everything we need is supplied for us from the RxJS package. So this is the same package that we use for writing our code and for testing. The second part is not actually about some disadvantages, but about some particular requirements, as they were mentioned on the previous slides, to our code to be actually testable. And these requirements actually make our code better. Thank you. That's it for Marble testing. And I'd like to mention that if you want to work on complicated, interesting, interactable UIs, you can join Grammarly. We are hiring in Ukraine, European Union, Poland, Portugal, Germany, US, and Canada. Thank you, and we are moving to the QA session.
Yeah, thank you guys. That's been really cool. So yeah, let's proceed with the questions and answers. A lot of them were in the chat, so sorry if I skip on some of them because they may be lost in the chatting. I hope that I don't. I had an interesting one. Sorry, I'll pick up at first. I'll pick my favorites, but I will try to cover everything. So the question was, where do you store ADRs and how do you collaborate on those? It's close to Gosha, I think.
I believe that everyone could answer, but yeah, I will take it. We are storing ADRs. They still in internal discussion on what is the right tool to store the RDRs and RFC, but in general, we are using 2 approaches. The one approach is using a shareable document. It's like GDocs, for example. And another one is to store them in code in Markdown format. So there are some pros and cons for all of them. So first of all, For GDocs, it's much easier to collaborate. It's more like suitable, I believe, for RFC approach when you just write a lot of context, a lot of some ideas and solutions, and you expect it to get the asynchronous comments for it. And yeah, it's better to use some tool that allows adding some comments, suggestions, and so on. But from the historical perspective, it's much easier to store them together with application, together with the source code. So some ADRs we are storing actually in the repository. Yeah, there is a history. You could explore. You can kind of open the blame and understand when and why someone updated it. So basically, when we use what, I believe for something that it's pretty internal to the client, some particular clients, we are trying to keep them in source code. Actually, in source code, you can use Markdown. You could draw some UML diagrams. How it's called? Plantum, for example, we are using Plantum to generate UML diagram from the text or from the code. Also, and something like GDocs or collaborative, we are using for cases when we're expecting pretty long and asynchronous discussions. Yeah.
Thank you.
Hope I answered the question.
Yeah, it seems so. Okay, let's go like in order. So do you have a technique to prevent backend suggestions, cancel, stop them, or are they always delivered to clients, but the client side decides whether ignore them or not? Well, I can take this one briefly. So we do have a mechanism to ignore suggestions. Actually, our users can ignore them. But in this case, if a user ignores a suggestion, the backend won't send it to us on the client. So we usually don't ignore backend suggestions only if they are delivered for a stall revision. For example, if user has already deleted some word and we suggest them to fix it, it's not relevant anymore, and it's quite a hard thing to do, like to keep track of the revisions and suggestions, as Denis talked about.
Also, I would like to add here, we have a few articles on our blog. I will find the links to them, actually, where we are explaining how we are working with incoming alerts and how it works under the hood. So yeah, it's fully async work. Of you cannot check text in synchronous way. So you need to use some technique to kind of limit this latency between responses. So I will post them. Oh, thank you, Vika. Yeah, Nastya, go ahead.
Okay, yeah, let's move on. Another one which I find extremely interesting. Usually testing is too boring for software developers. How do you encourage them to create sufficient amount of tests using different test methods? Well, I'm eager to answer this one. So it is a boring thing unless you worry about quality. So as Lyosha mentioned, software developers are really in charge of making the product as of the highest quality as possible. So it is in our interest to improve on testing strategies, creating checklists, just because no one wants to write post-incident reviews. I guess it's not a great pleasure, and it's just unsatisfying to to see a feature broken, and especially given that we have like millions of users, it is even more discouraging. So I would say just like that. It's about ownership. Maybe Losha, you have something to add, or Denis?
No, probably nothing to add. Yeah.
Okay. Okay, another one. Just a second. Let me grasp it. If an engineer has full content of a feature and can test everything without other points of view, why does he need other points of view on code? Why he needed code review?
Yeah, I could take it. Actually, I didn't mention that engineer could everything test by own. That's why, yeah, we are having so much reviews. So basically, for sure, the second eyes is really important here, and don't know what to ask. Yeah, we need a code review, we need a design review. We basically, during the code review, we are also doing a test review. So it's there in tests. It could be end-to-end tests. It could be unit tests. So yeah, it's everything goes through the review phase.
Yeah, and I can add on this. We have like for big releases, we have bug bash sessions when literally all the company is testing. So yeah. It's not only an engineer, but who is responsible, but still, yeah, still. How do you? Let's move.
Sorry. I would like to add here. Denis, would you like to add something?
I'd just like to add that often a developer that develops some feature has some developer's bias when implementing it. So some maybe particular flow, how it tests it, how it perceives it during the development. And the second point of view just adds this ability to test it from a different perspective. And also we have for editor and for a couple of others UIs, we have a large monorepo, and it's just split by packages that contain some other teams as code owners, and we cannot rely just on a single team to review each merge request when it just takes some other packages in consideration.
Thank you. Also, I would like to mention that basically that the fact that we are currently working without QA doesn't mean that we will never have a QAs. So it's not a religion, it's just a current flow. So basically at Grammarly, we are kind of considering all possible options and our organization structure evolving. So let's say 4 years ago, we had a QAs. We had a different layers, different setups. We had a separate team. We had a dedicated QA in within the team. We had a SDET, yeah, software developer in test, IT. So currently we don't have QAs, but yeah, it's still there are some talks, some consideration whether we need to involve QA. So basically, for sure, we are as company grows, we are facing with new challenges. There's still a lot of integrations between products and so on. So we always reassessing our flow, basically how we work. And if at some point we will understand that we cannot longer so basically work without QA doesn't effective for us, for some particular teams, then we will actually open this position of QA for as software developer test or so on. But yeah, but currently we are working without them.
Okay, thank you. Let's move to the next question. How do you automate regression testing and maintain feature coverage metrics? Well, I can take on this one, like from the perspective of my team, which I'm working on at the moment. We have Cypress along with Selenium. We're in the process of migrating from Selenium to Cypress. So some folks found it like more reliable and more stable. And the question about feature coverage metrics, I find it extremely interesting. So it's been a challenge, I guess, for us, because especially while the product is growing and its complexity is increasing, because we are adding like new features, and we are also adding new clients. Like not so long ago, we released our desktop client, so it became even more challenging to maintain like good coverage among all features, and all clients. So we do have like I would say a catalog of features in each team, and we are trying and we are trying like to keep coverage as big as possible, but it's not hard-coded in our process, I would say. So yeah, this is my take on it. And Denis, Lyosha, if you have anything to add.
Yeah, for sure. I would like to add a bit. So regarding the coverage, in general, we have some, I would say, the convention that everything should be covered with tests. It's also really depends on the project, and basically each project in Grammarly have dedicated team, and team thinks and decides what architecture, what processes should be. For sure, we have some company-wide guidelines. But yeah, it's still on engineers to decide how to validate that, how to verify the quality of product. For some projects, we are checking coverage. Yeah, I saw the mention of jest. Yeah, it's jest and coverage reports. So you could set up your CI or your repository UI, how to call it, to somehow validate this, to show this coverage, to probably block if it's decreasing. For some projects, we don't use this approach. It's really depends on the case. One more point regarding the measuring coverage with end-to-end tests. We had this experience far ago. The issue is that to check coverage with, let's say, WebDriver, IO, or Selenium, or whatever, you need to instrument your code. And basically, when you are instrumenting your code, it's not the same like in production. So it behaves slightly. It may behave slightly different, and that was the issue. So currently, we didn't practice end-to-end coverage, at least for online editor and extensions. Yeah, thank you.
Thank you. Just a second. What is the ratio between manual and auto tests?
It really depends on the product, and as I mentioned, it really depends on the how many time do you have to spend on writing automations. For online editor, I believe there's zero manual regression, so everything is automated. Still, it's a website, and basically you have a lot of tools that could provide the full coverage for your features. Let's say for browser extension, we still have some manual regression, but it's only because it's much harder to test, to set up the environment. So basically, currently we are working towards decreasing the manual regression till let's say 5 or 10%. So it will take like so we are imagining something like to spend not more than 20 or 30 minutes per release cycle. So basically, for sure, we have a different release cycles depending on the client. So websites, we fully own it. So we are leveraging on continuous delivery and actual every merge into main branch and ends up on production. But for clients that needs to pass store review like keyboards, native apps, extensions, so basically you need to pass you need to went through the web stores, a Chrome web store or its app store review. Then the release cycle a bit different. It could be, let's say, week, 2 week, or a few days. But anyway, it's not it's not exactly the same like in let's say online editor or web editor. How many releases? I probably saw a question regarding to the releases. So basically, for online editor, we could have as much releases as we can, as our CI could handle. Yeah.